everybody? Oh, where's everybody? I guess it's that snowstorm out there. You can be first. Well, I hope you had a nice weekend. I did. Got a lot accomplished. And so, it was a great weekend. Plus, I got to see some good soccer games on TV. All right. On Friday, I was talking about the mole concept, and the mole is probably one of the most important general concepts in all of chemistry. And the mole is the chemist's counting unit. Just like a dozen is how many eggs you buy. I don't think you can go into the supermarket and say, hey, I'd like to buy 2 eggs. No, they won't sell that to you. You buy it by the dozen. And same thing, bakers use a dozen for how many donuts you're buying, bagels, or other things. But the chemists use the mole. And one definition of the mole is it's equal to 6.02 times 10 to the 23rd units or things. And as I mentioned last week, my all-time favorite birthday gift would be a bowl of pennies. It's just the pennies, a bowl of pennies, which would be more money that's ever been on this planet and will be on this planet, because I figured out one time that'd be 100 million piles, and each pile has $1 billion. So you do the math. It's a lot. But it's just pennies. So a mole is a large unit. When you look at Avogadro's number, 6.02 times 10 to the 23rd. And I was showing you some, all right, relax when I say this word math. And 1 mole equals 6.02 times 10 to the 23rd. And when you have one thing equal to another in the definition, where 1 mole is defined as 6.02 times 10 to the 23rd. By the way, 6.02 times 10 to the 23rd is a calculated number. Therefore, for this class, and most of what I've ever used it, 3 significant figures. But when you have one thing equal another, you can have 2 ratios. And therefore, if a mole equals that, I can have these 2 ratios. And because of that, this plays an important role of doing calculations. And last week, I introduced you to my good buddy, my good friend, unit analysis. Remember, I'm still going for the Guinness Book of World Record, saying that the most times in the next couple of weeks. Hopefully somebody's keeping account. And because of that, these were 2 important ratios. And now, if I were to ask the following, what would you do? And we went through this, but I'll do this one, and I'm going to let you have fun too. You know I share the fun in here. And the question is, how many molecules HBr, HBr is hydrobromic acid. We'll learn later on in the semester what is an acid. If you don't know what it is, are in 7.891 moles of HBr. Well, what do? Well, first of all, what I like to do is write down what am I being asked to find, both the units and the molecule. You'll see later on in the semester that's important. The next thing I write down is what am I given? I'm given this, and on test 2, like on test 1, I'll have a page with important information. In the past, I made students memorize this. Good news, About a year ago, I changed my philosophy on that. Good morning. And this will be given to you. So you don't have to memorize it, but you still have to know how to use it. So let's look at how do we proceed. We're trying to find how many molecules of HBr. We're given this number. And the only thing we have to start with is this number. And don't forget the units. And now, once again, time to use your good buddy, your good friend, unit analysis, my good friend and buddy for many, many years. And how do you use it? This is what I'm starting with. What am I trying to get to? Well, look at the units. Molecules of HBr. And now if I had a magic ratio, it's not magic, it's chemistry, that I could convert this to this, what would I use? Well, you look over here and say whatever unit you're trying to get to goes on top of the ratio. You look at the units you're starting with, whatever you're trying to get starting with goes underneath the ratio on the bottom. Why is that? Because anything divided by itself equals number 1. Therefore, moles of HBr divided by moles of HBr becomes 1, and it's canceled out. Where do you get those numbers? From this. Knowing that 1 mole equals Avogadro's number, there are 2 ratios. And one of the ratios is for every 1 mole of HBr, any atom or molecule, you have Avogadro's number. And before I pick up my calculator, I'm going to use my good buddy, my good friend, unit analysis again, see if I'm on the right track. And what you do is, this divided by this becomes number 1, so it's 1. Because 1 times anything is that thing. Be careful when you do this, make sure that and that are the same. I've seen students just automatically do that, check. And now what units am I left with? Molecules of HBr, which is what I'm trying to get to. So I know I'm on the right path, and now I'll pick up my calculator. And the wrong number again. I always check. And now I have the right number, 7.891. Keep an eye on me once in a while. I do make that mistake. On a calculator, hit enter. This is the number my calculator used. Now, on test 2, like test 1, it will say, please use proper significant figures for all calculated answers. So what do? You look at this and say, how many significant figures? All non-zero numbers are significant. 1, 2, 3, 4. And here, this is a calculated number. How many significant figures? 1, 2, 3. Remember, 0 past the decimal is significant. 3. This is an exact number. It's part of the definition, 1 mole. Therefore, we don't use it. What's the lowest number? 3. I'm going to let you try. I'll give you 8.7 seconds. Go. Round it off to 3 significant figures. I've got to start my clock. Time's up. All right, keep the 4, keep the 7, keep the 5. Those are your 3 significant figures in the front. And what do you use to round off? 0, is that 4 or less? Yes, so you drop it. If it was 5 or greater, you drop it, increase the 1 in front. So if I have 7.891 moles of HBr, I know how many molecules. And this turns out, you'll see later on in this chapter, to be an important concept to be able to do in chemistry. How important? Well, I don't know about you, but it was nice that I had soap to wash my hands this morning. And if we didn't know about this, you'd never have that made. If you like a number of things like this plastic, your cell phone, all is based on this. So it's important. Yep. All right, let's do another one. And why don't you try this one? To set it up, you don't need to have a calculator. And the question is, how many moles sodium iodine are in 6.01 times 10 to the 25th molecules of sodium iodine? And this will help you. Remember, use your good buddy, your good friend, unit analysis. I got one of those click counters. Click another time I said it. Look up and smile. Don't make a crazy face. Don't make no face at all. All right, anybody need more time? Going once? Anybody need more time, don't want to raise their hand, raise their hand. Okay, didn't work. All right, let's do this, and you'll find a practice. Ooh, that reminds me. Time out. Time for a commercial from Dr. White, the manager of me. This Tuesday and Thursday in lab, I will be going through the practice problem set for Chapter 5, Balancing Chemical Equations. I highly recommend all of you try it before I do it, and that will help you. I guarantee there will be at least 9 points on test number 2 where you have to balance chemical equations. Better than that, I'm going to promise myself, there'll be at least 9 points on, or maybe more, on test number 2, balancing chemical equations. I might have mentioned this, but I'll mention it again. That's my knowledge. I have never, ever broken a promise to myself. Not to other people too, but especially myself. All right, let's do this. How do you begin? Well, you look at this and say, what am I being asked to find? Moles, sodium iodine. What am I given? One number. How many molecules? And now, how do I proceed? Well, this is the only number I have. By the way, once you've done this, you never have to look back at this again. That makes your life easier on the test. Also less mistakes. At least I found that personally when I was taking tests. So this is the only number I have to start with. And now, what unit am I trying to get my answer in? Well, you look over there, you already figured that out. Moles sodium iodide. And now, you use your good buddy, your good friend, unit analysis. Whatever units I'm trying to get to goes on top of this ratio. Whatever units I'm trying to get rid of goes underneath. And now where do I get those numbers? 1 mole equals what? Well, if you look over here, 1 mole equals Avogadro's number, in this case in molecules. And therefore, I'll use 6.02 times 10 to the 23rd. Remember, before you go any further, check your units. Use your good buddy unit analysis again. Whatever I'm trying, if I look at this, this divided by this becomes the number 1. Someone was nice enough to write on the board, 8 divided by 8 is 1. Anything divided by itself. So this is canceled out. What units am I left with? Moles of sodium iodide. Ooh, that's what I'm trying to get, so I know I'm on the right track. And I should tell you, for all my tests, when you show the work and if you make a math error, you get, say if this were 5 points and you put down the wrong number, say 11, which is clearly wrong here, I'd still look at this and say, oh, you made a math error of 4 points. If you don't show your work and you put down 11 and it's wrong, you get 0 points. So it always helps you to show your work. All right, now let's do the math. I put everything in right. And this is the number I get. Now, as I said, on test 2 and every one of my tests in the final, it will say, please use proper significant figures. Let's look at this. How many significant figures? This has 3. This is the exact number. This has 3. So my answer should have 3. I'll let you try first and I'll do it. Round that off to 3 significant figures. I'll give you 3 seconds. All right, time's up. Put down your pencil. No, I'm just practicing for the next test. Anyways, if we look at that, it would be 9 point, first significant figure 9, second 9, third 8. We want to round off. 3, is that 4 or less? And the answer is yes. So I will drop that and everything afterward. So I have 9.98 times 10 to the first power, and that's how you use it. Your good buddy, your good friend, unit analysis. Now, why did I pick sodium iodide? How many of you have ever been to the supermarket or with someone or see your parents buy it, where you bring home the container of salt and it says iodized? Have you ever seen that? And what does that mean? Well, they mix sodium chloride with sodium iodide to iodize it. Now, that's supposed to prevent certain diseases. I think it has something to do with goiter or something around there that they started adding that eons ago, well, before I was born. That was a long time ago. Anyways, even longer than that. Now, if you're a cook, and I think I mentioned it, if somebody's a really good organic chemist, they're a good cook. If they tell you they're a good organic chemist and not a good cook, they're lying to you. All good chemists are good cook. But anyways, sodium iodide makes table salt taste different. If you try the kosher salt, which has no sodium iodide, if you're not a little kid, you really don't need it in your diet, and that tastes different, tastes better. And that's why if you watch cooking shows or if you cook, unless you have little children that you need to put that in their diet, use kosher salt, which doesn't contain that. All right, let's try one more. And the question is, how many molecules of silver are in 7.011 times 10 to the 5th? And I should so used to writing. That's correct. Once in a while, Dr. White makes a mistake, but I told you that the first day. How many atoms of silver are in 7.011 times 10 to the 5th moles of silver? And use your good buddy, your good friend, in an analysis. Proud of all of you, you're working on this, trying to do it. Remember, practice makes perfect. It helps you on the test. All right, looks like everybody's done. Let's get moving. All right, the question is, how many atoms of silver are in 7.011 times 10 to the 5th moles of silver? So the first thing I'm going to ask myself is, what am I being asked to find in what units? If we look at this, we're being asked to find atoms of silver. And that's, what are we given? Well, this number right here. And now once I've done this, I don't have to look at the problem again. And now it's time to use your good buddy, your good friend, unit analysis. Whatever I'm given, that's the only thing I can start with, so I will. And then, what am I trying to convert that to, or what answer am I trying to get? And the answer to that question is atoms of silver. Now, once you have it set up, if there's some sort of ratio, something divided by something, I can convert that to that, then I can do the problem. Now, how do you figure that out? Once again, it's time for me to say, use your good buddy, your good friend, unit analysis. By the way, you're just going to have to suffer through me saying that, because it is true. And how do you use unit analysis? Whatever you're trying to get to units, go on top of this ratio. Whatever units I'm trying to get rid of, go underneath or in the bottom of the ratio. I just thought of something from first grade. How many of you remember a fraction is the numerator divided by a denominator? I haven't thought of that in a long time. And the teacher told us, remember, NV, Notre Dame. I went to Michigan State, we hate Notre Dame, but anyways, I still remember fractions. But back to this. Where do we get the numbers that go in that fraction or that ratio? We change the screen. And remember, 1 mole equals Avogadro's number. Therefore, you have 2 ratios. If I have 1 mole here, what do I have on top? Avogadro's number. And if I look at this, I'm going to say, before I pick up my calculator, I will say, do my units cancel out so I get the right answer unit-wise? If I look here, we'll have moles of silver divided by moles of silver. Anything divided by itself becomes the number 1. And now this cancels out. What's left? Atoms of silver. Hey, I'm on the right track. And now I can pick up my calculator. Come over here. I'll check I have the right numbers. I do. Hit the enter button. And here's what my calculator gives me. Now, remember how many significant figures? I'm going to let you figure it out all on your own, then I'll tell you what's right. How many significant figures should your answer be, and what should it be based on that number? All right, let's take a look. When you do a multiplication division, you get the same number of significant figures in your answer as the number you're multiplying and dividing that has the lowest significant figures. This has how many? 4. This has how many? 3. This is the exact number. What's the lowest number? Hope you all picked 3, not 4. And therefore, how do you round that off to 3 significant figures? Keep the 4, keep the 2, keep the 2. Use the 0 to round off. Wow, I'm on a real run here. All of them have been 4 or under. But anyways, it's real life. So this rounds off to 4.22 times 10 to the 29th atoms of silver, which means you've got a lot of atoms of silver in that amount of moles. And that's how you use unit analysis, your good buddy. And remember, you should know how to use, by the way, if it gets loud out there, feel free to close the door because you'll hear it before I do, anybody who's sitting by the door. All right. And therefore, you should know how to use, I no longer say you should memorize, 1 mole of a compound equals Avogadro's number, which is 6.02 times 10 to the 23rd atoms or molecules of that compound or element. And don't forget, you got a lot of times on my birthday, Dr. White just wants 1 mole of pennies. pennies. All right, let's move on. We've done our practice time. Another important concept when it comes to using moles is what's called molar mass. For a compound, that's the sum of the atomic masses of all atoms in a molar mass. Your instructor will call this molecular weight, which is abbreviated, I'll use on the board, MW. I'll never ask you what is molar mass, but I'll ask you to know how to do the following. All right, you don't have to copy the slide, but for those of you who do, I'll wait. Oh, tonight at midnight, I'll be giving a speed note-taking lesson. All right, let's move on to the next slide. Remember, everything I put on the projector there on the screen is available to you on Blackboard. All right, so what is molar mass? And molar mass is the sum of all atomic weights. I thought I had a slide in there. But anyways, yeah, I do. On the top it says that. This is something you should know. I'll never ask you it. Now, it's time for a gift from Dr. White. I'm so excited. And my gift to you is, for my class, and I do it in real life too, when you're calculating molar masses, use atomic weights to 3 significant figures. When you're calculating a molecular weight, use atomic masses to 3 significant figures. And that makes your life a lot easier. So what does this really mean, molecular weight, molar mass? Well, let's look at the following. Say 5 points each, or 3 points, depending on my mood. Determine the molecular weight, or the formula mass is another thing. Let me do it this way. Let's start out with something you're quite familiar with, H2O, and I hope you all know that's water. And the question is, determine the molecular weight for water. So how do we do that? Well, we clean off the board. And we say, what is the molecular weight? It's the sum of all atomic weights of the atoms in that molecule. So you have 2 hydrogen and 1 oxygen. You'll be given a periodic table. I don't expect you to memorize these things. Let's go to my favorite periodic table. Now, if you look at the periodic table, you'll see for a hydrogen, right up there, and the nice thing about this periodic table is I can do this, and you can see my mouse doesn't want to move. My mouse. You can see that the atomic weight for hydrogen is 1.008. However, these are the 3 significant figures. Round that off, and that becomes 1.01. So there are 2 hydrogens. And now if we look at oxygen, and for those who didn't bring your glasses, you can see it better now. It has an atomic weight of 15.999. Round that off to 3 significant figures, and the answer is 16.0. molecular weight is the sum of all atomic weights. 2 times 101 is 2.02. 1 times 16.0, 16.0. Add them up. This is the number you get. Now, on test 2, it'll say, please use proper significant figures for all calculated answers. So it's time now to teach you something I skipped earlier. How do you do significant figures for addition? For an addition, you have the same number of significant figures past the decimal as the number that has the fewest significant figures past the decimal. Everything on this side of the numbers you're adding, you ignore. You're just looking past the decimal. So how many significant figures? Every number past the decimal is significant. That's 1. That's 2. And therefore, what's the lower number? 1. You should round it off to 1 past the significant figure, or past the decimal. Keep that. Use that to round off. It's 4 or less, and drop it. So, the correct number, the molecular weight for water is 18.0. Now we'll learn later on to use 18.0 grams. So, molecular weight of water, stuff in this bottle, 18.0. Let's try another one. Let's do ammonia. And the question would be, same thing, determine the molecular weight for ammonia. And how do you do that? The molecular weight is the sum of all atomic weights and if you look at ammonia, ammonia has 1 nitrogen, 3 hydrogens. Now, what do? You take the sum of all atomic weights, and we come over here, nitrogen has on the periodic table, and mine is the one I give you on test is similar, something like that, and you round it off to 3 significant figures, keep the 1, keep the 4, keep the 0. Use a 0 to round off, less than 4, and therefore this is 1 times 14.0. We've already done hydrogen. And now I'd ask you, what's the correct molecular weight for ammonia? Remember, additions, you have the same number of significant figures past the decimal as the number that has the fewest significant figures past the decimal. I'll give you a little time to figure that out. Ooh, we're doing good time-wise today, too. Time flies when you're having fun with moles. All right, let's take a look at this. If we look at this number, how many significant figures past the decimal? All numbers past the decimal, including 0, are significant. 1. Remember, this side you ignore for significant figures. How many past the decimal here? 2. Which is the lower number? Hopefully you picked 1. Therefore, if I look at this, I say I keep the 0, use this to round off. It's, guess what, 4 or less. So the correct answer for the molecular weight of ammonia is 17.0. I'll let you try this one, and I'll help you out in case you can't see it. This is sodium hydroxide. We go to larger font. And I'll help you out on the test. I won't do this. We look at the periodic table, sodium Na. On here is 22.990. I'm going to put that down on the board, but you round it off to 3 significant figures. Oxygen, 15.999. Hydrogen is 1.008. And why don't you try that? Just set it up. If you don't have a calculator, just put down the numbers you think you should be adding. Those who haven't noticed, over the weekend, one of the things I did was get myself a pair of new shoes. I need them. I tested them out so far today. My feet are nice and comfortable, which being on my feet today is an important thing. One of the nice things, and I'm getting kickbacks from the company, but I really have been for many years a New Balance fan. All right, let's do this. First of all, how do you do the molecular weight of sodium hydroxide? It's the sum of all atomic weights in the molecule. So we have 1 sodium, 1 oxygen, 1 hydrogen. What's the atomic weight of sodium to 3 significant figures? 23.0. What is it of oxygen? 16.0. What is it of hydrogen? 1.01. Add this up, and this one I know by heart because I use this number a lot in my work, and I still do consulting. It's 40.01. Now, how do you figure out proper significant figures? Well, for addition, you look at how many significant figures are past the decimal. This one, 0 past decimal is significant. Same here, and 1 is also. Which of those 3 numbers, 1, 1, and 2 is the lowest? Hopefully I'll pick 1. So my answer should have 1 past the decimal. I keep this to round off. Is it 4 or less? Yes. And therefore the answer is, what is the molecular weight of sodium hydroxide? 40.0. And let's do one more, and I'll do this, because it shows you an important concept that you already know, but I just want to reinforce it. I have calcium nitrate. And the question would be, what's the molecular weight of that? Well, I look at this and I say I have 1 calcium. Now, notice the polyatomic ion, which I've used that term before, so you hopefully know what it means, is in a bracket. You multiply whatever's in the bracket times to the outside subscript. So how many nitrogen? 2 of them. How many oxygen are there? Well, inside is 3, but you multiply times the outside 2, and that's 6 oxygen. And now we'll do the math. I go to my periodic table and look up calcium. You'll see it's 40.1 to 3 significant figures. Let's take a look at what I did. Keep the 4, keep the 0, keep the 0. What do you use to round off? The 7. Was that 4 or less or 5 or higher? Hopefully you all know it's 5 or higher. So that's 7 made on a drop, and the 0 I'll increase by 1 to 1. So that's how I got 40.1. Nitrogen, we've already done, 14.0. Oxygen, we've already done, and that's 16.0. did my math correctly. If not, someone correct me quick. And now we add it up. And now we look at that, let's just check, 1431. One of the things when I was young, like about 5, my mother was an accountant, and she expected all of us to be able to add things like that up in our head. Because when you went to Marshall Field, they didn't have, this is a long time ago, cash registers that did the addition, or you scan it in and it automatically does it. The clerk would write it down in a slip and add it up. And sometimes they weren't good at adding. My mother expected us, by the time we were 7 for sure, to be able to add it up upside down and make sure the clerk did it right. And they wouldn't always. But anyway, what's the correct answer? Well, how many decimal points, how many significant figures past decimal point here? 1. How many here? 1. How many here? 1. How many should my answer have? 1. So the correct answer for the molecular weight of calcium nitrate is 164.1. And again, when you're doing addition, it's a little different. You forget about what's on the left and you look at the significant figures there. So that's how you do molecular weight. Now, why do you need to know molecular weight? Well, there's the most important concept when it comes to moles is molar mass. And molar mass is a way of determining other things. And for elements, what's the mass of 1 mole, or otherwise known as molar mass? That's equal to the quantity in grams of that element equals the atomic mass of an element. So 1 mole of an element equals its atomic weight. Now, for a molecule, 1 mole, which is called the molar mass, or here we call the molar weight, the quantity in grams of the formula molecular mass of a molecule, which equals the formula mass of that molecule. In other words, if I have 1 mole of something, that equals its molecular weight. And what that really means is I'm out of time. So everybody, for lab tomorrow, wear proper clothing, you need your goggles, you need the lab that was due last week, you want to get 11 points, and have it in, and don't forget the to-do list.